Hello friends, in this video we will run Hadoop program or Hadoop map reduce application, and we will try to understand the life cycle of the job, and also we will try to interpret the log information, um, and then we will also try to go through the counters, a concept called counters, when we actually run the map reduce programs. So now again I am going back to my Cloudera VM, and I will try to run the map reduce program on the Cloudera VM. So as I have been telling you in the past, you can use your terminals like PuTTY or Cygwin or whatever terminal you are using to connect to Cloudera VM. Only caveat is you need to be up to date on the changing IP address. And the way you get to the IP address information is by running ifconfig -a, and then using this IP address, I am on my terminal on Mac, and you can do SSH this is not mandatory, but why I am recommending is that you are I saw a lot of people getting confused uh, uh, on this topic. So to avoid the confusion, and to simulate how you typically run your map reduce programs in your projects, I am re-emphasizing this thing many times, and it is highly recommended to use the terminals on your PC, like PuTTY or Cygwin or Mac terminal, to connect to the server where you want to run the Hadoop command, map reduce applications, and then run it from your terminals instead of running from your virtual machine. So let me run it now. You can now we will run the same command, same map reduce application. Row count is the program which have the main function, which have the job configuration and all, and we have to give the input path. Last video we have seen deck of cards. Now we will see large deck.txt, and then you can give output path. Output path is again a directory, and you have to make sure that that output directory does not exist. Let me increase the font a little bit. And then if you see, first it is trying to connect to a process called resource manager, and that is the master which will control or queue all your jobs and make sure your jobs run. In this series I will not be explaining in detail about the complete flow, but what I will try to explain is whatever is the relevant information for the developers when they run the job. The first thing you need to understand is this URL. Okay, first it will give the job ID, and then it will give the URL for your job that is running at this time, and you can use this URL, and you cannot run it from your Cloudera VM because quick start you can run it if you create a entry in your etc host. You can copy on your PC, and you can copy and paste this URL on your PC, and you can see the results. but here it is not possible because I didn't do that. It is possible actually. The way you can do it is you can go to your browser, copy paste the IP address, sorry, URL, and change the IP address. In our case, IP address is 192.168.90.133. 168.90.133. And then if you hit enter, or else you can even go to Firefox on your quick start VM. It is still, as I have only 8 GB RAM and I have only 4 GB given to my VM, it is having some performance issues. It is taking quite a lot of time. So we'll go to our VM and we will try there. So I have launched the VM. Yeah, even it came back on my PC. So this is how you can monitor your job using the URL which it has given when you run the job. And and then you can click on this job and you can see how many mappers are running and how many how the job is running. So far we have spoken about map function and reduce function. Here it is showing information about your map tasks and reduce tasks. The naming conventions are little confusing, but whatever you are seeing here are the process, and these process will invoke the map function as I have explained earlier. So we have 52 cards in our file. If you are running against a small deck, and in as part of your map function, the framework APIs will make sure the data is read from the files, and map function is invoked for each line and do the necessary and then it will execute the necessary logic, and the output will be emitted to reducer. So there are two things which you need to understand here. First, when we run the Hadoop command and we say this getting started map reduce.jar and try to run the program in a cluster where there are many nodes, this jar file will be shipped to those nodes. So that is called pushing code to data instead of data coming to code, which is the behavior in our legacy architectures. When it comes to running Hadoop MapReduce applications, uh, uh, code will go to the data. So this jar file will be shipped to multiple nodes in your cluster where your map tasks are running, and then on each of them the code will be executed. So you just need to remember that code goes to the data. In this case, code is the jar file. As we have only one node, everything is on the same node. So but if you have multiple nodes in the cluster, as there are 6 splits, this number of splits are equal to block size by default. So for each split there will be a map function, a new JVM will be created, and that will be actually invoking the map function for each and every record on 6 JVMs. So now you are achieving the distributed computing using this. So the number of splits will be equal to number of mappers, and then you can use the URL to track the job, and also you can monitor the progress on your while it is running at command line, and also you can monitor your job at using the web interface like this. Okay, and then one of the most important details are counters and configuration. If you click on configuration of the program, it will display all the configurations that are effective at runtime. So as any software, Hadoop also comes with a bunch of parameters, and you have to make sure that whatever if you become a little bit advanced programmer in MapReduce, you can search those parameters from here and make sure the parameters are same as what you are expecting. So for example, you are familiar with block size and replication factor. So you can there are parameters which define in a set of parameter files when we actually set up the cluster, and you can override at runtime to make sure that the block size and replication factor are appropriate. You can search about it here. dfs.block size is the one for block size, and then dfs.replication is the replication factor. On our Cloudera VM, the replication factor is 1. So this is about configuration at runtime. If you want to know what is the configuration of your job at runtime, you can click on the configuration. And then second information is counters. So to make sure the job is progressing, you can click on the counters tab, and then it will give you a lot of information. It can the first one is file system counters, which will talk about IO. You can go through this by running your program on largedeck.txt. I will zip it and share it with you. You can unzip and you can run your MapReduce program against it, and I will share it on GitHub. And then MapReduce framework will give how many records are there as part of your map input, and how many records are emitted as part of our map output, and it will also give the reducer details. So reduce input groups is 1 because we have only count as input, but reduce input records is total number of values in all the arrays for all the keys. So in this case we have only one key and one array, and that array have one for each record in your deck of cards, and eventually once the program is done, these two will match. Okay, and you can refresh the screen to make sure your program is running successfully. Similar things you can achieve by clicking on the map tasks. It is a little bit slow. So you can run your program, and you can I will recommend you to go to your Cloudera VM and uh, paste this URL which we have seen. I think even in that it might take time, because it is using six mappers. It is taking a lot more time than I thought. It is using a lot more resources. That is the reason why it is taking a lot more time. Okay, now the program is completed. So we can click on map tasks here, and you can see your map programs are successful, and you can click on these and you can see the counters at each map level. So you know if one of the map is running very slow, you can click on the map and go to the counters, keep refreshing it to make sure it is progressing. Okay, so that is about UI, and once the program is done, uh, uh, so we came to here using a different URL, this one, which we copied from our output. But once it is successful, it changed the URL to job history. So once the job is done, it will go to something called job history server, and the URL will go there. and still all the information will be available in the job history server. So in a cluster, this URL. So if you have a 3 node cluster, this URL might be pointing to different IP addresses at runtime, because each MapReduce job will be forked from a different node in the cluster, using something called application master, and that will actually monitor the job. And in this case, uh, we have only one node, so always the URL will be this one, and this application ID will be changing. So this the first part till proxy will be constant, and the application ID will be changing. So what is the purpose of job history server is, as applications might run on different nodes in the cluster. Once they are successful, they will all the logs of all the applications which are MapReduce jobs will be pushed to job history server, and you should have access to the job history server to look into those jobs once they are successfully run. So, being said that, this is how you can run the job, and this is the progress which it is showing at command line. You cannot get the counters and configurations while it is running that easily. You can get it, but it is not that easy. It is better to use web UI. Once it is done, you will get the same information what we have seen earlier as part of the counters. So we have file system counters, job counters, MapReduce framework counters, shuffle errors, all the information, and it is very important to look into this information whenever you run the MapReduce job. It will give a lot of insights, like the amount of IO it is doing, how much records are being processed by mapper, and how many are being emitted by mapper. So it is kind of a smoke test for your MapReduce jobs. So for example, in this case, by looking at this information, we can estimate whether the program is successful or not. We are doing select count, so there should be only one record which will give you the total count. And in this case, input is 54 million records, output is also output of mapper is also 54 million, and input for reduce is 54 million count comma once, and output of the records, reduce output, number of records of the reduce output is only one, so which is matching our expectations. If it is giving some other value, that means there is something wrong in your logic. Similarly, if you are filtering the data in map, and if you know approximately how much percentage the map is supposed to filter, by seeing this information you can figure out whether it is doing its job or not. So it is very important to understand the counters information. And there is a while running the jobs, there is a concept of frameworks which are called as MRV1 Classic and Yarn. For entry level developer, or the developers who just introduced the MapReduce, it is too much to introduce them at this time, and they are not required at this time. It is more of a administrator responsibilities, but in most of the courses they put a lot of emphasis on that. But for a typical Java programmer who want to just learn MapReduce, I don't think you need to worry much about this. The only thing you need to worry is how to develop your program, how to run it, and how to interpret the results. And one of the thing you need to focus is this number of splits that will tell you whether the program is running distributed or not. And also you can go to the web UI and you can see the number of reducers it is using. Number of splits are determined by the number of blocks of your file, whereas number of reducers by default is 1, and there is a theory behind how to determine the number of reducers, and developer has to provide number of reducers based upon that theory. I will not be covering it at this time. In the advanced courses, those details will be covered, and if you are interested, you can explore how to determine number of reducers for your programs. I hope you enjoyed this session so far. In the next, sorry, let me. Yeah, in the next program, we will evaluate the results. Sorry, in the next session, we will evaluate the output that is emitted, that is computed, and then we will conclude the session. I hope you enjoy it so far.